You'll find walking in our campus on a typical day somebody from GM, GE, Enbridge, or whatever in the community, talking to our faculty, meeting with them, discussing their particular needs for doing research. We are looking at using hydrogen as an energy carrier and using a technique called thermochemical technique to produce hydrogen without burning fossil fuels. I do believe that in my lifetime we'll see complete power plants powered by perhaps renewable energy sources, geothermal or hydrogen powered. I think the era of complete reliance on fossil fuels is gone. At UOIT, we have several projects dealing with renewable energy or using different sources of producing energy. Perhaps one of the most fascinating one that I like is a project that is done with the Ontario Centre of Excellence and 3 companies in Toronto. And it's called the Solar PV Sound Barriers. What is it? It's a system by which they embed PVs, which turn light into electricity, and they put them on sound barriers along the 400 highway series. So by that you are providing means by which you reduce the noise for the neighborhood, but also the sound barrier will generate electricity now that can power the homes and the malls along the 400 highway series. I consider that a very forward-thinking project. When you look at energy consumption, for example, we can look at it as engineers from kind of the hardcore science, looking at gadgets and instruments and why people consume more. But in practicality, you have to really get to the psyche of why people use or consume energy at their homes the way they do. We monitor energy use in over 300 homes in the Oshawa area, and we interview the residents to try to find the trends for energy consumption and try to nail down what are the essential factors that companies and governments have to focus on to enable consumers to reduce energy. It is the second largest geothermal system in North America, capable of delivering up to 8 megawatts of energy for heating and for cooling in the summer. So it's a large heat pipe, so to speak.
We have a system here called borehole thermal energy storage system. And what that means is that during the summer, when the buildings are hot, we extract that heat and pump it into the ground through heat pumps and a series of holes that are drilled into the ground. So the grid amounts to about almost 400 holes. So at the end of the summer, we've actually heated up a block of rock about the size of a football field in area and about as deep as a 35-story building. So we've raised the temperature of that rock all summer, and once we get to the fall, we reverse the process and then start to take that heat back out again and put it into the buildings. If you want to relate it to your household units, a normal household unit is about 2 tons of cooling. That well field is 2,000 tons of cooling, so it could cool 1,000 homes.
When the institution was birthed in 2002, the founding fathers found it wise to build an institution that walks the talk. By that I mean they wanted to build the institution as a green institution. So the buildings are all green, and they are what we call the silver LEED category.
We have triple glazed windows that rated at R9. We have energy recovery wheels at the top where we're taking heat out of the exhaust air and putting it back into the intake air.
It is a large laboratory. You can look at it this way. And despite the fact that the capital cost was quite significant, the founders felt it is important for this institution as it moves to become a preeminent institution in the energy research to actually show it by example.